Hi guys, my name is Tito and welcome back to my YouTube channel. So it's around 4 a.m. in the morning when I'm recording this video. So if you have few minutes, I urge you to please stay and watch this video from end to end. So this video will cover a topic that can be very helpful for everyone, because as you all know that if you want to become a data analyst or data scientist, you need a good knowledge of statistics. So that's why I have decided that in this video I'm going to share a statistics roadmap that in just 1 month will teach you statistics to such a level that you won't have any problems going forward in data science or data analysis. Okay. So before I jump into the main part of our video, let me ask you something before we dive in. Okay. So you have decided to learn machine learning. Okay, that's an amazing choice. But if you open YouTube or maybe a Python tutorial, maybe even a course, and then someone mentions like p-values, Gaussian distribution, and the bias-variance trade-off, and suddenly your brain just shut down. Sound familiar, right? Yeah, I know that because we have all been there. But here is the truth that nobody tells you. Machine learning is basically statistics with a fancy outfit. So you don't need a PhD, you don't need to memorize thousands of formulas, but you need to understand the right concept in the right order. Okay. Before we dive into the concept, let's answer the big question. Why does statistics even matter for machine learning? Think of it in this way, like machine learning is about making predictions and taking decisions from data. But real world data is messy, it's incomplete, it's noisy, it's uncertain. But statistics give you the tool to understand, interpret, and validate that data. So every machine learning algorithm builds on statistical foundation. Without statistics, you can't understand why your model is failing. You can't tell if your results are meaningful or not. Even you can't choose the right algorithm for your model. So with statistics, you become a more confident and a smarter machine learning practitioner. So statistics is very important for machine learning. Okay. So let me show you the roadmap that I have been created, and I created the entire curriculum on Google Sheets, so it's very easy to share with everyone. Maybe you can find it on my description of this video. So if you have spent around 2 or 2.5 hours daily, then you take around 1 month or 60 days to complete this full roadmap. So now I break down the whole video into 5 clear statements, and you have to keep in mind that you need to just follow the order, then only you can easily understand everything. Okay, so stage 1 is about the foundation. So think of this as the ground floor. So without it, nothing else will matter. Before you dive into the complex things, you have to be familiar with basic terms. Like you need to understand the difference between a population and a sample. You need to know that what is a random variable is. You should also be comfortable with basic algebra, calculus, things like working with equations and understanding what a slope means. And that's honestly enough to start your journey as a machine learning or a data scientist. Next is stage 2, that is descriptive statistics. So in stage 2, we move into the descriptive statistics. This is where we learn to describe and summarize your data. And trust me, every machine learning project starts from here. This includes univariate, bivariate, and multivariate analysis. So here is what you will cover. So first is measure of general tendency. So you will learn about mean, median, mode, etc. So what is mean? Mean is the middle value when you sort your data, and it is very useful for handling outliers. Next is mode. Mode is very useful for categorical data. Next is you can learn about measure of spread like variance, standard deviation, quantiles, percentiles, etc. Next you will learn about covariance and correlations, and this is very, very, very useful for feature engineering. Next, we will learn about data visualization, like a histogram for distribution, box plot for spotting outliers, scatter plots for feature relationship, etc. So before you run a single machine learning model, you have to visualize your data, and you can imagine that you are building a house prediction model. So before your model before you make the model, you have to check that if your data is skewed or not, where actually your skewness and curvature concept will use. You have to also see that if there are any outliers are present on it or not, because if your data has outliers, then your model will not perform well. So you have to be familiar with this also. Next is probability theory. This is the key area where things are getting extremely interesting, as the entire hypothesis testing depends on this. So you probably learned basic probability in class 12th grade, and that's enough to get started. But we need to go deeper down into probability distributions. Like we need to know that core concepts of like PMF, like what is probability mass function, PDF, probability density function, CDF, like cumulative distribution function. You should know that all of these things. You must know the big one, like you should also know the distribution, like normal Gaussian distributions, uniform Bernoulli, binomial distributions, Poisson, log normal distribution, etc. You'll find all of these in my sheet that I attached in the description of this video. We also touch some kernel density estimations, what 2D density plots look like. You also need to understand all of those things. Finally, we will wrap up this stage with one of the most important theorem of the data science, that is central limit theorem. This is very important for data science and machine learning engineer. Next is stage 4, that is inferential statistics. Now we are getting into the most powerful stuff, that is inferential statistics, where you will learn about make decisions and predictions from your data, like hypothesis testing. And this is how scientists and machine learning engineers prove whether something is statistically real or just a coincidence. You will learn about null hypothesis, alternative hypothesis, p-values, and type 1, type 2 errors. In machine learning, this type of errors directly related to precision and recurrence classification models. So you have to be notice all of those things. Next is confidence intervals. So like instead of saying that my friend's salary is around $70,000, you need to say that I'm 90% confident that my friend's average salary is in between $68,000 to $70,000, and it shows that how reliable your estimation is. Next is some key statistical tests. So you will learn about t-tests that helpful for comparing means of 2 groups, ANOVA tests that help you to comparing means of 3 or more than 3 groups, and if you want to build a relationship between categorical data, then you need chi-square test. Next is stage 5, and this is where everything actually clicks. In this final stage, we will connect statistics directly to machine learning alongside some miscellaneous but crucial topics. Now, what are the miscellaneous topics? Like we'll look at the Chekhov-Speed inequality, QQ plots, sampling, resampling techniques, statistical movements, and get a brief introduction to Bayesian statistics. Next is machine learning connections. So we dive into the linear regression, cross validations, and the bias-variance trade-off. Okay, next we'll learn about dimensional reduction. So when you have too many features, now what is features you will learn later, but when you have too many features, then it gets messy. You will learn principal component analysis, that is PCA, which uses linear algebra and statistics to reduce features to keep the most important information intact. Now remember, all of this becomes 10 times more powerful when you practice with code. Make sure that applying this concept using Python libraries like NumPy, Panda, SciPy, and Seaborn. Now let's come that whatever I shared in the previous talk, that is important for your study, but now let's answer that how to study. So in future I will share some learning videos, but now I can share some YouTube videos that you can actually prefer to learn. I highly recommended that statistics fundamental playlist by StatQuest, an awesome channel to learn machine learning visually. I've also linked a great statistical playlist from IT Matters that you can also follow. Now, if I talk about books, I have added one book that in the description of this video, which is incredibly popular, that is ISLR, Introductions to Statistical Learning. While it's broader than just statistics, but it's the statistical foundation in this are really very good. You can follow that one also. Now the goal is very simple. Okay, I want to create a highly organized and powerful statistical resources so that whenever anyone wants to learn statistics for data science, they know that exactly where to go and how to start their journey. So if you think that any topic or good resources is missing in this video, please let me into the comment sections. Otherwise, if you enjoyed the video, please like the video. If you haven't already subscribed to the channel, please do. That's all for today, guys. See you in the next video. Thank you.